When you perform registrations in ANSR or ANS or in LESYMAP, one thing to consider is what type of registration do you perform. If you don't know anything about that, don't worry about this video, just keep going, and by default you'll have the optimal registration parameters by calling the register lesion to template function. However, if you want to know more, one of the parameters in this function is the type of transform. This is obtained directly from the answer registration function in ANSR. And typically we use the SyNCC, which means SyN with cross correlation. What this function does is actually use the surrounding, the neighborhood areas of each voxel to try to maximize the similarity, not of that voxel with the matching voxel in the template, but also the surrounding voxels, so that the gyra can match as better as they can. However, there is an option to specify just SyN instead of SyNCC, and in that case the type of transform will use a mutual information similarity metric instead of cross correlation. Now, one thing that you might be curious of is how do these two registration measures compare to each other. Note that the default one, the SyN cross correlation, take about 1 hour on this computer, and the other one, the simple SyN, which uses mutual correlation similarity metric, just takes about 2 minutes to run. So you might be asking whether it's worth waiting an hour for a registration. And in here I just want to show you one simple example. I'll open the template and I'll show you first the regular SyN cross correlation, the registered subject with the stroke lesion. Okay, and this is one and this is the other, and now I'll also add in there the simple SyN. Okay, and this is SyN. Let me get out of contrast. So let's first, they are very similar, the two registrations are very similar, but you can see that the deformation is a bit different from one to the other. Okay, so to understand which one is better, you can try to check the ventricles here, for example. But you can also see which one is really in shape more similar. And you can see that the regular one, the SyN cross correlation, which is also the longest, matches well with the template. But if we flip between the template and the SyN, there is slightly worse registration. Let's see. So this is the difference between the template and the regular one, and this is the difference between the template and the fast one. You may or may not want this kind of meticulous registration. It is up to you. All I want to show you is that they produce quite different results, so you may or may not be willing to compromise on the registration. And this change is pretty obvious here. And by looping in 1, 2, and 3, you can try to understand. Let's focus on this specific area here. You can try to understand which one is better. And if you loop here, the difference is a little more pronounced. One other area to look at is this frontal area. There is a pretty good, if you also see the overall shape of the brain, there is a pretty good registration between and matching between the registration and template for the regular one, but when you switch to the fast one, the match is less good. And it can also be seen how the two differ from each other. This is all. I hope it's helpful.